Okay, and we're back. So now, let's do some welding. So I got my torch lit up, I got my neutral flame ready, and I got a nice piece of 20 gauge sheet metal here to weld on. So what we're gonna do is just make a puddle by melting metal. So you can see it goes blue as the heat goes into the metal. You can see that it turned red, but I didn't get a puddle. What you want to look for is like this little shiny orange bead that looks like a orange M&M or Smartie, and that's your actual puddle, right? And there it is. See it? And I can move it along like this, and I'm melting metal. If I go faster, it'll go away. If I go slower, it'll get too big. And if I go further away, it'll get smaller and go away. If I go too close, it'll get bigger, and maybe even if I stay too long, blow a hole through. One thing's for sure, it's putting lots and lots of heat into this coupon. It is warping it for sure, right? Which is why, and then at the end, there was nowhere for the heat to go, so it blew a little hole out of the end, right? And you can see the rainbow sort of effect to that coupon, where the heat score is super duper wide. So that little tiny, like 3 or 4 millimeter bead made a heat score. It's like, I don't even know what that is, like it's huge, right? Might as well be a mile. It's very, very hot. Too much heat for modern cars, but still an awesome thing to be able to do, an awesome thing to be able to see. So I'll do one more bead for you guys, just for the puddle. And then I'll do a bead with rod for you, okay? So I'll do one out here. We'll get a bead going. There's the puddle. I'm just going to move it along. Try to keep it the same size. Try to keep it liquid all the way along. Pretty shaky. Too many coffees today. Sometimes shaky welds look really nice though. They have a nice like pattern, like a stack of dimes. A lot of welders sing as they weld. Okay, so there's our just a bead, and you can see that it's actually undercut because there was no filler material put in. So now we'll do one with filler material. And what we're gonna have to do is make the puddle a little bigger, because as the rod goes into it, it's gonna cool it off. Right? Now what I'm doing is just putting some material from the rod into that puddle to fill it up and give it strength to the carbon that the torch is removing. Like so. Okay, and that is a weld without adding filler material and one with filler material. And you can see the filler material weld is not undercut and would definitely be stronger when it's done, right? Okay. So now we'll do one more. We'll do a brazing rod just for you to see it, because it's totally different again. Totally different. Sorry, I'm waving the camera around everywhere, but it's attached to the torch right now. So now we're going to pick up a brazing rod. And brazing rod is totally different. We're not creating a puddle because it's not a fusion weld. We're melting brass on top of it. It's more like gluing than it is like brazing, right? So I always preheat the metal like this. That prevents it from cracking because the brass and the steel have two different expansion rates. And then we're going to melt the brass onto the surface like this and make a nice golden bead all the way across. And you can see I've changed the angle drastically because I'm not trying to create a bead. I'm not trying to melt it into the coupon. I'm trying to just melt the brass on top because it's like glue. You can think of it like hot glue, right? Now the green stuff that's on the outside of the rod is now green stuff on top of the brass. That's flux. It's acid flux. It helps it stick and it shields it from oxygen while you're welding. That gets chipped and then scraped off afterwards, but that's how old school brazing is done, right? And that's pretty much what it should look at. I'm not very good at it, so my bead's not very even. With some practice I could probably get some nice ones. Some of the old guys that work here are really, really good at it because they did it so much in their career, right? So that's sort of oxyacetylene welding in a nutshell. Okay, and we're back with the cutting torch. So the cutting torch has an oxygen valve on it that allows you to increase the heat for cutting, right? So what happens is you put it on the metal, you melt it, and then the extra oxygen blows it away and it slices through like a butter. So the metal's being heated to the point of melting, and then the oxygen just blows it through. And then we get sliced molten metal. So that's the cutting torch head. And it's the same, it's just you take the gooseneck off and you put the cutting torch blade on. The only real difference that you do is you set the oxygen flame by a secondary knob I'll show you in a second. On the torch handle, you leave the oxygen wide open. The cool thing, because everybody always says, why do we have to learn how to oxyacetylene weld? The cool thing about it is if you can learn how to oxyacetylene weld, which is pretty easy, you can learn how to TIG weld, which is really hard. And if you've never oxyacetylene welded before, learning how to TIG weld is twice as hard as learning if you already know how to oxyacetylene weld, right? So this welder is a little bit more complicated and can do a lot more things. I'll show you the cheat sheet for it. Sorry the torch is in the way, but this is the cheat sheet for a TIG welder. A little more complicated than the cheat sheet inside the MIG welder, right? So I'll show you how it's the same though, because all what this does is makes a puddle with an electric flame, an arc, instead of a actual gas flame, right? So I'll show you how similar it is. So we strike an arc just like the flame and we create a puddle right there. See the puddle? And you just go along just like the torch. It almost looks like a flame coming out of the end of the tungsten. TIG stands for tungsten inert welding, right? And you just go along and make a bead like that, right? And it looks exactly the same. This is a piece of stainless steel, but it looks the same, right? You can just see that it has a smaller heat score because the flame is more controlled, it's more focused. And I'll show you when I add the rod, just like I added the rod, because you can see this is undercut now, right? Like the first flame weld was. So we'll add the rod and you'll see it looks pretty much the same. So there you can see the nice pretty TIG weld that everybody loves to see. You can do the exact same looking weld with the torch. It'll just be a little more boiled, and it'll be a little wider heat score because the flame does so much overheating, right? So that's something to be excited about. You guys get the TIG weld in level 3. If you get done your welding in level 2, you can try it out as well. So don't crap on the gas welding, because it's not done in the industry anymore. It's the core fundamental skills of fusing two metals together, creating and running a puddle. And once you understand those concepts, once you get how to make metal molten and control it, TIG welding is like a walk in the park. Like, you just use the little cheat sheet. It tells you a baseline for the settings, and you have the ampage roll on your foot. This is like how much flame is coming out, basically. The tungsten here, the gas lens coming over top of it, and then you feed the rod in. It's sort of like a combination of gas welding and MIG welding at the same time. So it's something to look forward to. The school has 2 of these TIG welders for you guys to play with.